Hello, welcome to Electronics Education. I am Vincent Chang. Thanks for coming to the lecture. Today we are going to analyze a MOS amplifier, MOS amplifier. MOS, common source amplifier. Analysis by inspection. Here's the common source amplifier. A MOS, metal oxide semiconductor, common source amplifier. Common source is grounded, AC grounded. Signal comes in, external signal comes in through the gate. And output signal is taken from the drain. So gate in, drain out. Common source amplifier. So when you conduct an amplifier analysis, so always remember you need to find out the DC first. You have to conduct the DC analysis first, operating point analysis, the transistor's bias. So here's the bias circuit. The bias circuit. So ask a device, what's your opinion? What's your characteristic? The answer, the square law. The transistor has to be biased at saturation, bias in the saturation region. So the relationship between the drain current and the VGS follows the so-called square law. Half Kn VGS minus threshold voltage and square. And also you need to ask the circuit, the network. So what's your opinion? The kickoff voltage law. The opinion, the characteristic is this. The terminal voltage equals the two drop. The sum of two drop. The terminal voltage is VSS. The first drop, VGS. The second drop, the drop across the resistance RS. And you solve these two equations simultaneously will give you the point, the operating point. In other words, you can use the graphical analysis on the diagram of the ID versus VGS. Vertical ID, horizontal VGS. The first equation, a MOS, square law, a parabola. And the second one, load line. So the intersecting point of the parabola, based on the MOS saturation characteristic, and the load line, based on the kickoff voltage law, will tell us the answer, the operating point. The bias current, IDQ, and the bias voltage, VGSQ. So once the DC bias current and the voltage has been solved, then we have no problem to figure out the small signal parameter. The first parameter, let's say transconductance. The small signal transconductance and also the small signal output resistance. Right? This is the small signal parameter. So based on the small signal parameter, we have something to plug in once we figure out the expression for the input resistance, output resistance, or small signal voltage gain later. So now, here comes the small signal analysis again by inspection. Okay, by inspection. So I challenge you to go higher without thinking about the small signal. Without drawing, you might be thinking about the equivalent, but save time, okay? Just save your time. Just to challenge yourself. Input resistance, easy. Because the resistance between gate and source looking into gate is infinite for MOS. So RG. The output resistance, the O in parallel with RD. The drain, RD, between drain and the ground, and also the internal one, the output resistance of MOS. What about the voltage gain? It's not hard. The voltage gain is the Ohm's law, negative GM, the DLO, and then the divider, the Rin divided by the total series resistance at the input side. Here's the outcome. Small signal voltage gain. Now, we still need to, this is the lecture, so I still want to, if you have any question, let me just go through. But if you think you're okay, you can skip this. Okay, go to the next lecture. And for the equivalent circuit, and then R, G, VI. Hybrid pi model. The gate, the floating gate, the voltage control current source, G and VGS, the output resistance, internal RO, external RD, and the external RL. RG, input resistance, RG, easy. For the output, RD in parallel with RO. Let me ask you this. What about G and VGS? How are we going to handle the voltage control current source? Open circuit. Why G and VGS can be treated as open circuit? Why? Because when you set VI 0, VGS will be reduced to 0. And the value of the value of the current source can be reduced to 0 as well. Can be treated as open circuit. The small signal voltage gain, Ohm's law, first term. The dividing rule, the second one. Here's the takeaway. The first takeaway, always remember, before you jump into the ACL analysis, then what about GM? What about the output resistance? So it has to come from the operating point analysis. It's the simultaneously solve these two equations based on the MOS characteristic in saturation region and the kickoff voltage law, the DC load line. So the intersecting point between the parabola of the MOS and the load line from the bias network will tell us where the operating point is. DC analysis. So once we get the DC analysis, then we can move on to the AC one. AC analysis by inspection. RG, RD in parallel with RO, and also this is easy. So we have now come to the end of the lecture. Thanks for watching.